Hi, I'm Andy Peel from CCDC, and welcome to this video on processing and analysing disordered structures in Mercury. This tutorial features the Disorder Analyser tool, which is available in the 2023.2 release of CSD software and subsequent releases. If you are unfamiliar with the Disorder Analyser, we recommend first watching Visualizing Disorder in Mercury. In this video, we will show how the Disorder Analyser integrates with other functionality in Mercury. Specifically, we will see how the analyzer handles short contacts and hydrogen bonds, how it interacts with void calculations, and how it allows for structural editing of individual disordered components. These examples assume that you are working with CIF files. The CIF files used in the examples shown can be downloaded from the link in the video description. Alternatively, you can download all CIF files from Access Structures using the ref code identifiers displayed with each example. Let's open Mercury and get started. To load multiple CIFs, go to the File menu and select Open, then select all CIFs and press Open. Alternatively, you can drag and drop them into the visualizer area. They will appear in the Structure Navigator near the bottom. We'll start off by looking at short contacts using CSD entry HAXPIH. To see short contacts, tick Short Contacts in the display options. With all disorder groups visible, all possible short contacts between disordered groups are displayed. Clicking the button for the first assembly updates the contacts so that they are only visible for the combination of disorder groups currently displayed. The default is the first group of each assembly. Toggling the various disorder assemblies updates the contacts accordingly. Using CSD entry GEHFAE, we can see that this also applies to hydrogen bonds. To see hydrogen bonds, tick H bonds in display options. Initially, we see hydrogen bonds between the non-disordered OH of the dysprosium complex and the disordered oxygen atoms of the trifluoromethylsulfonate anion. Clicking Disorder Assembly B removes the minor group of the disordered anion, leaving a single hydrogen bond per anion. Toggling Assembly B updates the hydrogen bonds to show only those of the minor disorder group. Returning to CSD entry HAXPIH, we can view the voids by going to the Display menu and selecting Voids, then clicking Apply with the default options enabled. The voids will become clearer by ticking Packing in Display options. With all disorder groups visible, the percentage of the unit cell volume reflects that remaining after the volume occupied by all disorder assemblies is removed. Clicking on any one assembly in the Disorder Analyser causes both the visible voids as well as the percentage unit cell volume reported to update. Iterating through the disorder assembly/group combinations reveals a potentially much larger void volume of 9.1% for one disorder configuration. In the last part of this video, we will see how the Disorder Analyser interacts with structure editing tools. Bond types are not assigned in CIF files and must be interpreted by Mercury either upon loading by enabling Auto Edit Structure on load, or by processing with Edit Structure, which can be accessed from the Edit menu. We have taken the CIF of disordered CSD entry JASROO and removed all hydrogen atoms for the purpose of this demonstration. We can see that there is one disorder assembly with two groups present. From the Edit menu, selecting Auto Edit and clicking Apply with the default options enables successfully adds hydrogen atoms to both disorder groups and correctly assigns the bond types in each, as we can see by toggling the Disorder Analyser. To summarize, the Disorder Analyser in Mercury not only offers great versatility for visualizing disorder, but also makes it easy to calculate, manipulate, and view associated structural features. We hope you've enjoyed this video. Thank you for watching, and don't forget to subscribe to our YouTube channel.